It's interesting being involved in the MDMC from another university, because one of the key issues we have is that we have a lot of manufacturing equipment, but it's not focused on the centre. And something to stress is that access is not available free of charge. So what the other universities do is provide additional facilities that MDMC doesn't have internally, which will have to be paid for. But if a company has a process that involves one step beyond the MDMC, then that may still, of course, be very cost effective. And it certainly provides potentially access to understanding of different equipment. So I'm from the James Watt School of Engineering at the University of Glasgow, and I'm just going to tell you a little bit about what we're doing in healthcare technology. There are some weasel words at the bottom of one slide which explain why I'm not going to talk in as much detail about specific equipment as Mark and Duncan have. So healthcare technology in the school is part of the overall activity of the school. We're a multifaceted engineering school with approximately 140 staff and 10 being recruited just now. Turnover is about 50 million, and we had a good year last year, and approximately 30 million of research grants were awarded. So overall the school is in good shape. It's organised in 5 divisions, one of which is biomedical engineering. And you might think that that would define our healthcare technology activity, but in fact it doesn't. Biomedical engineering has 17 academic staff, approximately 50 staff in total, plus the same number again of research students. But activity in the school as a whole in healthcare technology is much larger, approximately 50 academic staff, so 3 times the number in biomedical engineering. And that is a deliberate part of how the school works. The staff beyond biomedical engineering aren't exclusively involved in healthcare technology, but they do from close to 100% to relatively little, but with useful capabilities. Examples of what we do, I thought I would show you. One of them is rather famous, organic diagnostics. John Cooper, a very senior member of the school, has been working on this for a number of years in collaboration with people in Uganda and in China. Margaret Lucas, another senior prof, is working on ultrasonics for surgery. Although there's no scale bar on the smaller looking tools, they are actually much bigger than this miniature tool, and the idea is to mount that tool on the end of a robot to enhance surgery. And our head of biomedical engineering himself works in tissue engineering for regenerative medicine, including doing a first in dog trial, which everybody was rather impressed by. To get back to more factual stuff, we did a recent staff survey on the 50 staff that are working in healthcare technology, and we found that 70% of them approximately are working on sensors, about half on materials, electronics and software, and 30% working in robotics, with several other areas, obviously using a lot of manufacturing capabilities. The capabilities themselves, there's a very long list, but here are the weasel words at the bottom of the screen. There's no central database of equipment. With MDMC just forming, it's delightful that it has a proper record of its equipment, and it's all focused and available. When I was working in Scottish physics, we tried to set up a database of all the equipment across Scottish physics that could be accessed by industry, etc. And that was a somewhat impossible task. So we don't have a central database of equipment, and we have to proceed with individual contact. But some examples in micro and nanofabrication, working a bit below the scale that Mark showed you. The James Watt Nanofab is genuinely a world-class clean room. We have a huge list of companies that use that. It's not cheap to use, but it can be very valuable in doing one particular step, for example, in a manufacturing process. We also have a lot of additive manufacturing, more than 100 machines when we did the census. We've recently been joined by Shan Kumar, who's Reader, so one step below Prof. And he's a specialist in additive manufacturing, and will be acting as a focus for that in the school. And we also have a lot of projects in state-of-the-art electronics, relevant to healthcare, neural implants, capsule endoscopy, terahertz imaging, and multi-sensor systems. But as I say, no central database of equipment, so you have to look at the lists, you have to contact me and other people, and explore a bit. I thought I would more or less finish with a case study from my own work on on capsule endoscopy, also with Marc Demoulier. Video capsule endoscopy is well established. We set out to explore whether ultrasound capsule endoscopy is possible or useful. And the picture here is the artist's impression, actually a design engineer's impression of what we call Sonopill. And the picture below shows the Sonopill, a tethered Sonopill, hence the nice loop here, in its more natural environment in a pig model. And in terms of the manufacturing that was required for that, we used a wafer dicing saw, we used lapping and polishing, we used photolithography, we used electronics assembly, miniature electronics assembly, we used additive manufacturing, bonding and sealing, working with adhesives and things like that in an expert regime, and multiple test regimes. Some more slightly weasel words here. Many steps were done in-house. I need to also acknowledge that Heriot-Watt University was extremely effective also in contributing to the process. So the capsule you see here would start at Glasgow, for example, and go to Heriot-Watt, and then back to Glasgow and back to Heriot-Watt, and so on. Also to SMC, Scottish Micromanufacturing Centre in Edinburgh. So as a summary, the James Watt School of Engineering is a highly research-intensive school. Approximately 35% of our quite large staff have interests in healthcare technology. We have a huge range of relevant equipment. I've mentioned a couple here, but no central database. We are just starting a new initiative to increase external accessibility of capabilities in healthcare in particular. But meantime, if you would like to contact me, I would be very happy to guide you to an appropriate person. We have a network also of business managers who I can direct you to depending on your particular inquiry. We also have two of the ugliest buildings in the world. I thought I would just show you there. And a shiny new one on its way. University of Glasgow Research Hub is being built as we speak and will house approximately 20 of our engineers working in healthcare. So thank you for that. I'm very happy to answer questions either now or possibly if you'd like to contact